Welcome to quickcode.com. It starts with kuickcode.com. As you all know, algorithm and data structure are a very difficult subject, and it becomes even more difficult if you do not have any plan for them. When one prepare for data structure and algorithm, they generally face three basic problems. Problem number one, what basic data structure and algorithm one should be very good at. Problem number two, what coding problems one should practice, because there are thousands of them. You cannot practice thousands of them. You need to practice at least 100 of them. And problem number three, what is the overall strategy for the coding interview? For example, what data structure and algorithm and basic concepts you should revise 48 hours before the interview? What coding problems you should practice prior to 1 week of the interview? So those are the strategies that you need to be very prepared of. Now let's take the first problem, which is what algorithm and data structure you should practice in detail. So for that, if you come in the beginning of this menu, right, we have introductions. Those who are very new to algorithm and data structure, they should read it out, how interviews are conducted and what you should do in the interview, like clarifications. When a question is given, you should clarify the questions, and then once you clarify the question, you should provide the key insights, and then you tell the approach, and then you also talk about the asymptotic analysis, that is time complexity and space complexity, and then you should write the full code and then provide a test case and apply the test case, right? And there are a lot of things you can go through it, so I'm not going through it here. Now the basic concepts. So point number one, what basic data structure and algorithm one should practice. So we all prepare for strings, arrays, then graph, and all of these, right? But we do not care to understand how internally hash map and tree map works. Those are very important concepts one should learn. And there are basic maths which you need to prepare for. You cannot go in the interview and think about what would be the common series of like 1 plus 2 plus 3, blah blah blah. You have to just know it very on top of your head, so that you can quickly remember them. And there are many basic concepts that you need to learn. For example, prefix sum. What is prefix sum? Which is all explained in here. So there are many problems based on prefix sum, and there are many basic concepts that you need to prepare for as well. Some logarithm, because logarithm is used for analyzing the time complexity. So, and there are some more basic concepts are here. And basic Java snippets. This site is built on a Java coding problem. So here when we write Java programs, there are many basic things that you need to learn or remember on top of your head. Like for example, how can you convert a list of integer into an array of integer, for example here, right? So these are the code that you need to really remember them, because they are very handy. Now there are other basic concepts like what is a bottom-up and top-down approach. So that is very nicely and simply explained here using a Fibonacci number. NP, P versus NP problem, you can read this out. This is a very important concept that one should know. And binary search, right? Binary search is very simple but very effective. One should know how binary search work extremely well. So as you all know, we should prepare for like basic data structure like strings, arrays, graph, trees, but many times we forget to prepare for like tree map and hash map, how they internally work. Those are the very important concept that one should prepare for. And also one should prepare for the basic math which is needed for the interview, like for example the common series, the prefix sum, and there are many more. If you scroll down, you will find it. and basic code snippets. So many basic code snippets that you need to learn. For example, how to turn a list of integer into array of list, and we have bottom up and versus top down approach, which is one should know very clearly, and it is explained here with an example with Fibonacci number. And P versus NP concept, these are very important concept for the Google interview. And we have binary search. Binary search is very simple, but is very effective and important. One should have very thorough understanding of binary search. One should go through it to learn how binary search can be used for finding the insert locations, or for finding whether an element exists in the sorted array. And basic binary tree. So here all the basic concepts of the binary tree are laid out. And binary tree traversals, as you all know, there are 3 types of binary tree traversals: in order, pre-order, and post-order. And it is easy to implement them using DFS, depth first search. And also we have one level order traversal. So DFS is very easy, but you need to know how to do all of 4 actually: pre-order, in order, post order, and level order in iterative approach, iteratively, right? So all these pre-order is implemented iteratively, and in order is implemented iteratively, and post order also implemented here iteratively, and level order also implemented here iteratively. So these are very basic concepts one should know. And the basic of graph, right? The graph can be created using adjacency list and adjacency matrix, and both approaches are laid out here in this basic concept of graph. Then we have binary tree upside down. This is a very important and basic concept one should be very good at. And then breadth first search, and we have depth first search. These are 2 important concepts one should be very clear of. Then reverse linked list. Reverse linked list, it's very confusing for the beginner, but one should really be very good at reversing the linked list and making the binary tree upside down. And then we have important concept that one should learn, which is quick select. We know that quick sort, right? It sorts a list of integers, in ascending or descending order. And quick select is based on quick sort. So it doesn't sort all the elements in its sorted location. It sorts few selected elements in the sorted location and then solve some of the problem related to quick select. So one should really be good at quick select, because many problems are solved very efficiently using quick select. Then we have Jakarta's Digester's algorithm. One should go through it and then understand how Digester's algorithm work. Then we have disjoint set union by rank and path compression. This is extremely important concept one should be very clear of, because many graph problem is solved using disjoint set union by rank and path compression, and that is simply explained with example here. One should be very good at this. Then we have prefix sum. This is also a problem concept which is very easily laid out here in this place. One should go through and understand it, and we have a very good example in here as well. Then topological sort. This is also one of important concept that one should know how topological sort works. It is given here, explained in detail, and if you go through, you'll understand. Now this is the first problem that we you can handle the first problem, that is what basic data structure and an algorithm you should be good at. The second problem is what coding problems you should practice properly, because there are thousands of them. You cannot prepare thousands of them, right? So you have to prepare at least 100 of them. So here, week by week, for 10 weeks, you have 10 weeks preparations for 100 problems. Every week there are on an average 10 problems, so that you can prepare in 10 weeks, 100 problems. And these 100 problems are extremely highly sought after in the interview. And it is very likely that you will see this 100 problem, some of the 100 problems in the interview. This 100 problem is composed of, grind 75 and blind 75, which are two very important lists. Both lists are composed and compiled here in this place. So let's take some of the example. Week 1, right, contains duplicates, two sums, best time to buy and sell stock, merge two sorted lists, binary search, insert positions, valid anagrams, valid palindromes, blah blah blah. You can go more on these, right? Then week 2, add binary, climbing stairs, diameter of binary tree, fast bad versions, majority elements. For example, if you go to the detail of here, right, you have the problem statement laid out, and then you have the key insights and approaches. Key insights and approaches is explained, and you have time complexity and space complexity, and you have one very efficient code which is written in here. So when someone new and try to prepare for coding an algorithm data structure, then they should not solve the problem by themselves. They should see how these problems are solved efficiently by others. At least they should follow and understand the underlying concepts, how these problems are being solved, and before trying a new problem by their own. So that's very important. And this way you can save a lot of days and hours. And so week 3, 0-1 matrix, 3-sum, label order traversal, clone graph. Then we have evaluate reverse police notation. So for all of these problem, you have the problem statement, you have the clarifications, you have the key insights, you have the time complexity and space complexity, and you have an efficient solutions given here. So if you practice and practice and practice, you will get these concepts, and you will concepts and all these tactics that are used to solve this problem, so that you will have a lot of tools in your toolbox. So when you pick up a new problem, it will be easier to solve. Okay, let's see week 4. Week 4, we have course schedule, find fewest coins, mean stack, number of islands, product of array except self, rotting oranges, try is a very important data structure, which solves the string problem in a dictionary, finding a word in a dictionary problem. So one should understand these, how it works. Very important. Let's see week 5, accounts merge, binary search on rotated array, combination sum, okay, lowest common ancestor of a binary tree, merge intervals, permutations, search in a rotated sorted array. These are a few of them in week 5. Then you have week 6, binary tree right side view, construct binary tree from pre-order and in order sort, right? And then partition equal subset sum, spiral matrix, string to integer, blah blah blah. So these are very, very important coding problem one should prepare for. Again, you have the problem statement, you have key insights, you have time complexity and space complexity, and you have an efficient code to go through and understand. So week 7, container with most water, find anagrams in a string, LRU cache, letter combinations, etc. And then let's see what we have in week 8. So week 8, by the time when you come to week 8, you will have a lot of knowledge, so that you can pick up the harder problems marked by the red color, right? Basic calculator, and then you have binary tree maximum path, employee free time, find median from data stream, kth smallest element in BST, largest rectangle in histogram, maximum profit in job scheduling, merge case sorted lists. Again, all this problem has the problem statement, and then you have clarifications, you have key insights, and you have time complexity and space complexity, and an efficient code here so for you to practice. Okay, so let's see week 9. um, Invert binary tree traversals, counting beats, group anagrams, longest increasing subsequence, missing numbers, number of one beats, reverse beats, same tree, etc. All of these are very important and highly sought after in the interview. And week 10, alien dictionary, a valid graph, graph, a valid tree, jump game, longest consecutive sequence, longest repeating character. Okay, longest repeating character replacement. So these are very important problems for the interview to be prepared. So this is the 10 weeks worth of coding problem that you need to prepare before going for any coding interview. And if you prepare these 100 problems, there is a great chance to succeed in the interview. But once you prepare 100 of them, and if you think that you can take up more, then there are a lot more for you to to be master in the coding, data structure and coding, algorithm and data structure, right? We have a lot of other top rated problems. We have a host of binary tree problems, easy, medium, and difficult. You have a lot of tricky problems. You have more DFS and BFS problems. You have edit distance, word distance, and some miscellaneous problems, and many problems on arrays, and 2D arrays and mountain array, and many problem on binary search, many more problem on binary search and rotated array, and coin problems based on coins and combinations. And there are many problems on designs, design problem. These are not very hard, but you need to just brush through them. So you have more dynamic programmings and more graph problems. So if you really want to be master in data structure and algorithm, then you can go through all these. And obviously here the problem statement is given, and key insight is given, and time complexity of the problem is given, and an efficient code is given. So this is the so let's talk about the third problem, which is how to prepare for the coding interview prior to like 48 hours. What you need to do. So prior to 48 hours, right, you should prepare this hard problem at least once, because it's very difficult to remember for them. If you prepare today and if you go for interview 10 days later, you might forget. And what you need to do, 7 days before the interview, you should go through all these 10 weeks problem one by one, just eyeball them, and then understand what the underlying concepts are, and how it is being used in the coding. So these are in short some strategy which one should prepare before going to coding interview. And if you prepare them, there's a really high chance, I would say 80% chance to get a job after you prepare these 100 problems and go for coding interviews to 5 companies. And you are very likely, at least in my point of view, there are 80% chance that you will get a job at least one of the 5 companies. So that's it. Okay, before I finish, I should say that in this side you have my favorite, right? So my favorite, if you think that some problems are very good, and you want to pick it up from any of the list, say for example serialize and deserialize binary tree, right? So you can click in here, right? And then here you have add to favorite, so it will go. Okay, let's pick one more, some route to leaf nodes, right? So let's click this as well. And then if you go to favorite, you will see these are the problems that you selected, and you can also delete from the favorite. So this is for you, so that you can organize your coding interview on this side. So guys, these are the important concepts one should really know for the coding interview. So what I want to say, at least prepare 100 you know coding problems, which is categorized in week 1, week 2, week 3, and then you can prepare for coding interview, and then pass through the coding interview. And good luck. Thank you. Bye.